Okay, so today we'll do the longest substring without repeating characters. So you'll be given a string and you have to choose a substring which has all the unique characters, and obviously that substring should be of the maximum size. So for this example we can see that ABC is has all the unique characters, and it is of length 3, so we are printing 3, and you cannot find any other substring that has greater length than this and which has all the characters unique. So suppose if you take ABC and again A, you can see A is repeating twice, so this will be an invalid case, so we cannot consider this case. So any way you take other than ABC, you won't find any other substring which will satisfy this uniqueness property. So your answer is 3 in this case. So in the next example we can see that we are having 5 B's. So obviously the substring with unique characters will be of length 1, and that is only B. And if we move to the next one, we can see that only WKE, if you consider, then that will be unique, and if you take any other letter along with it, then the uniqueness is not retained. Okay, so let us see how to do this. So we can try the brute force approach, so that will take a very long time, so I'm not going to discuss that. So the simple thing which you can do is you can use a hash map or a hash set, and you can store and maintain the characters. So I'm gonna take this example, and I'm gonna say you why you need to choose hash map and not the hash set, because hash set there will be some problem which I will discuss. So suppose this is the example. So initially your uh, window is nothing, means both the ends of your window is pointing to A. Now you move your window, means your right pointer, to the next character. Now you see that we have unique characters, so then we again move this pointer to the next character. Again we see that we have all the unique characters, then we again move our pointer and we move the next character. Now we can see that we are encountering two A's in this span of window. We have two A's, so we have to move the left pointer that many times to make A out of the window. So obviously if we move the left pointer 1, A will go outside the window. So if we move the pointer to here, now A is not in the window, and now we have this BCA, and so this window is now valid. Next we again move this pointer to the next position, and obviously we keep track of the length. So the maximum length was up to this was 3, and uh, before that pointer was here, so that was 3 again, so no need of updating. So we are getting here, moving the pointer to the next character, but we can see there are two B's here, so again we have to move the left pointer so that B goes out of the window. Okay, so we will move this pointer to the next character. Now again we can see that B is out of the window, and we have a window that contains all the unique characters, and we will not update this length because it is of the same length. Okay, next we'll again move this right pointer to the next one. Again we can see that we are having two C's in this window, so we'll again move the left pointer to the next direction. Okay, and now we have a unique window where all the characters are repeated exactly once, but you see again the length is 3, so no need of updating. So again you can move it to the next element, and again in this span you can see B is repeated twice, so you have to move the left pointer so that B goes out of the window. Okay, so I'm moving it once, and you can see that B is still in the window, so you have to move again, so your pointer comes to here. Now B is out of the window and you have unique characters in the window, but you see you cannot update the length because the size of the window is less than this length. And now you again move your right pointer, okay, to the next one, and you can see that two B's are there in this window. So again we have to move the left pointer such that one B goes out of the window. So let us move this pointer to here. Again B is still in the window, then we move it again. So at this position we can see that we are having unique characters in this window, but this length is only 1 and we cannot update that. And next we cannot move this right pointer anywhere, so here we are stopping it, and we can maintain all the characters in the hash set and or hash map. Now why I am telling to use hash map? Because for example, suppose we have this, we have x like 100 times here before this sequence. So suppose your pointer is coming to here, and then your right pointer is coming to here, sorry, okay, not x y z, like x y z, some characters are there, okay, and your left pointer is here and right pointer is here. So now again you move it, and you see this, your right pointer comes beneath your A. Now you have to move this pointer as many times as to put this A outside of the window. So you have to basically move your pointer to here, and you need so many steps to move it because you don't know the location of this A. If you are using hash set, you don't know the location of this A. You have to move many times, as many times as you uh, not find A, you have to move it. So you can use hash map where you can store the index of every element. If you are storing index of every element, so suppose A's index is suppose 9, so you can directly go to this 10th index, because you know that 9 or before 9 it is useless because A will be included. You can directly move your pointer. So I would recommend you to use hash map. It will take less time complexity as compared to hash set. Okay, so let's go straight into the coding portion. So first of all, we'll define our hash map for character and integer. Okay, now we can do one thing. We can loop through the characters. So we'll increment I up to s dot length and I plus plus. Actually we can do it using two pointers, so I was talking about the pointers, so we can do that. So int ptr1 equal to 0 and pointer 2 is also 0. We can do like this, while ptr2 is less than s dot length, then only this while loop will run. And now we have to populate this map, and if map dot contains key, if map already contains the key, then we'll do something. So and okay, so first we need to take in the character, so that is char ch equal to, so we're extracting character at the ptr2 position. Okay, and we're checking if this is present in the map or not. Suppose this is not present, then what we will do, we'll just add this in the map and we'll do nothing. We'll just add this in the map and along with the index of it. And suppose if it is present in the map, then my ptr1 will be map dot get ch plus 1. So whatever the index will be, so if it is 9, my first pointer should go from here to the position after 9, so that means 10. That's why I am doing map dot get plus 1, and we can update pointer 2, sorry, we can update these characters to its new position, that is pointer 2, because when I'm putting it out of the window, its new position will be whatever will be this one, not this one. This one is out of the window now, so this is the new character or the new index which we should consider. Okay, so this is done, and after that we can do one thing, we can maintain the size of the index or size of the array or window. So I can write here int max, this stores the size of the window. So max equal to maximum of your max and ptr2 minus ptr1 plus 1, so that will be the size of the window. Okay, that you can easily see. Suppose here is your ptr1 and here is your ptr2, so this you can see is the size of 3. So if you forget all this, and if it is 0 1 and 2, if you subtract p2 from p1, that is 2 minus 0, that is 2, and if you add 1, so you'll get the window size, so that is 3, so which is the case. Okay, so we are updating every time, and then I have to increment the ptr2 pointer, and that's it. That should work, and at the end we should return our max. So that is it, guys. Let's see if it runs or not. Okay, for the normal cases it is accepted. Let's see if it is submitting or not. I forgot to mention the base case also. Okay, so I have basically got the error why it was not happening. So that is because when we are moving this window or shifting this window to our new case. So for this example, the case was not working. So our window was here and it went to here, then it again went to here, then the window had to reduce, so the window reduced to here, then again your left pointer increased, and when it got A in the map, A was not removed when the pointer went beyond A, but A is still remaining in the map, and we have given the logic as get ch plus 1. So the pointer, instead of going to the right direction, or it is means it should consider this window, because in this window only one A is there, but it the map already contains this A which we didn't remove, so it will think that it contains duplicate A. So the best way we can solve this problem is that we can just check whether this index is left of this left pointer or not. If this index of A is left to the left pointer, that means this letter is not in the window. So we need to just check that. So in this case, if it is in the map, we have to check that whether it is in the window or not. If map dot get ch is less than ptr1, then we just need to uh, update the map, the characters value, and nothing else we have to do, because that is not in the window and that will not cause any problem. Else which we need to do is that we need to update pointer 2 by the map value plus 1, and this is the, I think uh, this is the common case, so I could have done that. So I could have written like this, so and greater than equal to. So if it is greater than equal to ptr1, then the pointer ptr1's value I will move forward, the pointer I will move forward, otherwise I don't care. I'll just update these characters a new index position. Okay, and so then I will do this, and let's see if it is running for uh, this output. Okay, now it is fine, so let us submit it now, and now we can see that we have an accepted solution. So guys, please like, share, and subscribe. I want you people to subscribe, because I am uploading videos almost every day, and I hope it will be helpful to your courses.